Synopsys and Analysis are now united. Together, we will ignite the innovation from Silicon Systems, July the 15th, 2025. Today is a transformative day of the for Synopsys and is an exciting one for our employees, customers, and partners, as well as engineers, innovators, everywhere. We have completed the acquisition of the Ansys and the transition to combine the leaders in the silicon design, IP, and simulation and analysis to create the engineering solutions from a silicon to systems. Together, we will maximize the capabilities of the engineering teams broadly, enabling them to rapidly innovate AI-powered product. I'd like to explain why this next chapter for our company is consequentially for the future of innovation and assure you that you have a plan for a smooth and exciting integration of our teams, technology, and customer engagement. This comes at a pivotal time for innovators everywhere. Products are increasingly involved in an intelligent system capable of learning, reasoning, and collaborating, adapting, and acting. Well, it's a surgical or factory floor robot, an autonomous drone, an electronic vehicle, or a cutting-edge data center. This intelligent system are silicon-powered, software-defined, and AI-infused. Engineering teams face the unprecedented design complexity and cost pressure, while the pace of innovation accelerator. To tame these challenges, we must re-engineer how products are engineered. Integrating electronics, physics, and AI. Products are increasingly multi-domain systems. To build them successfully, every single part at every level must be engineered right the first time. Engineers need a new design solution with a deeper integration of electronics and physics augmented by the AI. With the Ansys now part of the Synopsys, we can give engineers the industry's most comprehensive solution to realize their innovation in software. For example, we can help the automotive engineers design optimization and virtualize the car's features and functions from the chips to chassis in all in software and before the start of production. Imagine in the future knowing the EVs actually range in the sub-zero teams without a real-world test, or knowing exactly how safety features perform without ever crashing a real car. Similarly, we can help the aeronautical engineers explore new materials and alternative fuels to reduce emissions. Imagine the fuel shipping planes gliding through the air as efficiently as sharks in the ocean thanks to the mimetic coding developed, test, and simulated software. And our integrated design solutions can help semiconductor engineers pack even more performance and features into smaller and multi-stacked chips while managing the electrical, thermal, and structural challenges of these impossibly complex and intelligent systems. Imagine that data center as getting smaller and more getting efficient because of a step function improvement in silicon design. The igniting innovation from Silicon Systems. Because of our shared culture and our strong, long-standing partnership, we are confident in delivering a seamless integration of our customers and partners. This includes the Ansys channel partners, who will continue to be an important part of our go-to-market approach. And for Ansys customers who are new to Synopsys, we remain committed to helping you innovate, reduce the time to market and cost, and improve product quality by continuing to develop the unprecedented insight you've come to rely on from Ansys. The combination of our capabilities will be game-changing, and we are fast tracking the development and delivery of holistic engineering solutions that enables the next generation of AI-powered product from silicon to systems. We expect to deliver out the first set of the integrated capabilities, which will fuse multi-physics across the full EDA stack, and including the multi-die advanced packaging in the first half of 2026. Our combined roadmap also includes the integrated solution to advanced testing and visualization of the complex and intelligence system for automotive and other industries. By re-engineering how the intelligent products are the engineers, we will ignite innovation from silicon, from systems, and empower the innovators in everywhere to drive human advancement. Forward-looking statement. This blog article includes a certain forward-looking statement within the meaning of the federal securities laws, including, but not limited to, statements that relate to our expected future for business and financial performance and anticipated the benefits of the transaction, the anticipated impact of the transaction of a combined business, and the expected synergies from the transaction. These forward-looking statements generally are identified as the word believe, project, expect, anticipate, estimated, intend, strategy, future, opportunity, plan, may, should, will, would, will be, will continue, will likely result, and a similar expression of the negatives of these words and other comparable terminology to convey the uncertainty of the future event or the outcomes. Looking forward, forward-looking statements are prediction, projection, and other statements about the future event that are based on the current expectation and assumptions, and as a result are subject to risks and uncertainties, and other factors could cause actual future event to differ. Materials from the look forward-looking statement in the communication, including that they limited to our ability to maintain the relationship with the Synopsys and Ansys customers, suppliers, and other business partners. So the effect of the transition, our operating result and business, our ability to implement plans, forecast, expected financial performance, and other expectations with respect to the combined business and realize the expected benefit, synergy as well as the manage the scope and the size of the combined company, the unexpected cost and charges expenses related to the integration. V. Our ability to successfully integrate the Ansys operations product lines. 6. Difficulties retaining the hiring key personnel and employees to do the integration. 7. The diversion of management time and integration. 8. Our ability to manage significant indebtedness, and including the indebtedness incurred in connection with the transaction, and the need to generate sufficient cash flow for the service and repay such debt. The uncertainty in the macro economy and geopolitical environment, and each potential impact on the semiconductor and electronics industry, and uncertainty in the growth of the semiconductor, electronics, and artificial intelligence industries. 11 is the higher competitive industries we operate in. 12. Actions by the U.S. or foreign governments, such as assessment of the fine and the imposition of the additional export restriction or tariffs. 13. The consolidation among our customers and within the industry in which we operated, as well as our dependence on a relatively small number of the large customers. And 14. The evolving legal and regulators and tax regimes under which we operate. Our filing of the Securities and Exchange Commission, which you obtained for free at its website at SEC governance, discuss more of important risk factors that they affect our business. Result of operational finance condition result may vary from the estimation provided. We undertake no intent or obligation to publicly update and revise any of the estimated or other forward-looking statement made in this announcement, whereas the result of new information, future event, or otherwise, except as required by law. Okay, next one is the same Synopsys article. Automotive coupling industry leaders discussed the race to define the car development. The Synopsys editorial staff, July 15, 2025. Table of content. Today's automotive industry has the accelerator storm to the floor, pushing the product development team to work at a breakneck speed. The new automakers, particularly in China, now release fully redesigned models every 2 years or less, which is half to the quarter of the time it takes car makers in Japan, Korea, Europe, and North America to stay competitive in a global market when the growth is leveling off. Legacy automakers, OEMs, are being forced to completely rethink how they are engineer cars, and even changing to concept of what a car is. The amount of change happening in the industry greater than it's ever been, said Judy Curran, automotive CTO and ANSYS, during the panel discussion at the inaugural Synopsys Executive Forum. All of the OEMs and their suppliers are having to re-engineer faster and change their product development process. Software and silicon, alongside data and AI, play increasingly critical roles in driving values and differentiating in cars. There is recognition how OEMs think about the product. Ravi Subramanian, Chief Product Management Officer in Synopsys, is it a physical, electrical, and mechanical system, or it is a software-based, service-oriented platform? Learn the secret to the trustworthy automotive semiconductors. Discover key strategies and expert insight to ensure the reliable and trustworthy automotive semiconductor. Software-defined vehicles. Sundara Rajan Ramalingam has a front row seat for the transformation. As VP of the Research and Development for Mercedes-Benz R&D North America, Ramalingam said the traditional OEM development model relies heavily on the front-loading requirement specification to a complex network of in-house and external suppliers. Our job is mainly in the integration of all these parts to test it over the life cycle to do a lot of validation before releasing the product, he said. But if you look at the edge OEMs, they are dependent on a lot of suppliers. They do not try to fight with these partners on development speed. This is especially true when it comes to a core technology. Software that is increasingly refined vehicles, similar to a consumer's product, and your car makers control the chip and the software tooling environment and the data pipeline, the seed for the development. When you control the complete tool chain, the agility lies on the hand of the OEM, said Ramalingam. As like many OEMs, Mercedes-Benz is trying to move from traditional signal-based architecture, electronic control unit ECUs that send and receive specific signals tightly coupled with hardware functions, to a service-oriented architecture focused on software, where new functions and third-party integrations can be delivered rapidly, even when the car is already in a customer driveway. As the vehicle ages, you will be able to update the software and highest level at the Curran. The goal is save money, because you can fix the orientations in the field, or you can sell a feature supposed to sell of the vehicle. But it's a long road to get there. A modern car has 80 plus ECUs, often from many different suppliers, each running its own software. Integrating the ECUs to achieve ultra-low latency drags out the development time. OEMs are now at the various stages of consolidating the EDUs down to 4 or 5 domains and general controller. There's a lot of work to be done, said Curran, the lead designing all modules, chips, and software, because that all needs to come together. Left to right, Sam Abul El Samid, moderator, Judy Curran, ANSYS, and Sudarajan Balamalingam, Mercedes-Benz, R&D in North America, and Ravi Subramanian, Synopsys, at a Synopsys Executive Forum. The virtualized validation. Targeting all of this complex and integrated system is another matter. Today, time-consuming physical testing or domain-related costing 60 to 75% of developed program. To reduce their cost and accelerate engineering processes, car makers are turning to simulation data and virtual models of the real-world scenarios. You need virtual models of the old sensors that you are reading and all the hardware you're controlling. So OEMs are creating the virtual ecosystem to validate the software, said Curran. We want to virtually develop, design, and test these vehicles, so we minimize the amount of time spent on auto prototyping. But it requires a platform where the suppliers can provide models that are competent so OEMs can validate the full system. You have multiple domains working together, and Subramanian. That is the biggest challenge in realizing the promise of the virtualization. New mindset, new skills. Developing cars with the software as a primary driver will require OEMs to completely transform their engineering processes, melding their methodical, safety-first culture that move faster approaching of the tech industry. The speed of innovation in China is creating a day of recognition for many engineering teams at Subramanian. You need a different mindset in terms of product management and how the engineers teams are staffed with skill sets. It's the biggest change in 100 years. While challenges remain, the exciting new era for the automotive sector is dawning, and one that will redefine how cars are designed, built, and tested and driven. Note, this article contains a statement made during a panel discussion at Synopsys Scientific Forum held March 19, 2025 in Santa Clara, California. Next one is the Marvell develops advanced packaging platform for custom AI accelerator. Marvell Technology has unveiled a multi-die solution for lower total cost of ownership (TCO) for customer or AI accelerator silicon, expanding the packaging ecosystem for AI infrastructure. This is the advanced packaging platform for custom AI accelerator. So this solution is part of the Marvell's IP portfolio custom AI computing platform, and it enables multi-chip accelerator designed up to 2.8 times larger than a conventional single-die implementations. This approach will enable more efficient die-to-die interconnection, low power consumption, increased chiplet yield, as well as lower product cost, according to the Marvell, and provided manufacturing alternative to traditional proposal-based multi-chip approaches. The packaging platform has qualified with major hyperscaler and is now ramping in production. Chip making has been critically increasing AI compute density while effectively managing power, thermal dissipation, and optical I/O, signal integrity, and other factors that impact the performance and reliability in the multi-die chiplet design. Simultaneously, there are challenges associated with rising supply chain complexity and extended lead times, and it comes to scaling advanced packaging solutions. According to Marvell, this packaging solution will enable hyperscaler to overcome many of these barriers, accelerating time to market while offering greater supply chain flexibility. This is the latest innovation in a series of advanced Marvell has introduced for its custom XPX solutions, which are the highly optimized multi-chip packaging platform that has been designed from the ground up with Marvell's custom HBM and CPU solution in mind. Taken together, Marvell is working to build a broad technology platform to enable improved custom XPU design. Advanced packaging is one of the primary vehicles for advancing compute destiny in the AI clusters and the cloud. And Will Chu, a senior vice president and the general manager of the custom cloud solution at Marvell, without the AI infrastructure would be significantly more expensive and power hungry. Chiplet constitutes one of the most dynamic segments of the semiconductor market. We anticipate the chiplet processor revenue. As anticipate the chiplet processor revenue will grow by 31% per year to reach $145 billion by 2030, said James Sanders, senior analyst at TechInsight. Advanced packaging technology are critical to a evolution of a chiplet, giving designers a framework in which to experiment. Interposers serve as a foundational layer with compute, dies, memory, and other components stacked above and communicating through the interposer. The Marvell distribution layer (RDL) offers alternative to traditional silicon interposer for data center application. It integrated 1390 millimeter scale of the silicon and 4 pieces of the high bandwidth memory, 3/3E HBM3 and 3E memory stacks, and utilizes 6 proposal RDL layers, which enables multi-die AI accelerator solutions that are 2.8 times larger than the largest possible single chip design. The Marvell multi-die packaging solution allows for shorter die-to-die interconnect modular RDL interposer. The interposer reduces the design cost through each modular design according to the Marvell. In the conventional chiplet, a single interposer will span the floor space of the chip. It connects well as any area between them. If you two computing cores are on the opposite side of the chiplet package, the interposer will cover the entire space. By contrast, the Marvell RDL interposer are form-fitted to the individual computing dies and connected by the high-bandwidth path. This approach reduces the need for materials and also increases the chiplet yield by enabling manufacturers to replace individual dies. So the Marvell multi-die packaging platform enables the integration of passive devices to reduce potential signal noise within the chiplet package caused by the power supply. In collaboration with the packaging ecosystem, Marvell has extended the solution to support multiple components within the single package, enabling the integration of the most complex AI design. In addition, the hyperscalers now employ the packaging technology to build the XPU, and with HBM3 and HBM3E memory, and Marvell said that it was actively qualifying the technology for future HBM4 designs. Okay, next one. The Broadcom aims to reimagine the Ethernet switch for HPC and AI. Announced today, new device challenges the assumption that Ethernet can't support small package sizes or optimized transport paths. Broadcom today announced that its Tomahawk Ultra switch IC has entered production. Designed from the ground up for the high-performance computing HPC and tightly coupled with the AI-scale networks, the Tomahawk Ultra is meant to dispel long-standing criticism of the Ethernet and latency sensitivity environment. Broadcom engineered the Tomahawk Ultra to transform the Ethernet switch to high-performance computing and AI workloads. The Broadcom's re-architecture challenges the assumption that Ethernet is inherently high latency and lossy, unable to support small package sizes and optimize transport paths. All about the circuits are heard from Peter Del Vecchio, as the Broadcom data center switch product line manager, to learn more about how the switch is changing narrative on the Ethernet. Addressing the Ethernet's shortcomings, Del Vecchio explained that Ethernet perceived shortcomings in HPC and AI scale-up data system historically stemmed from the design priorities of the traditional data center switches. These switches prioritize the high throughput for the large package size and global scale deployment. What we decided to do was the first off-the-shelf with misconcept every design point that was not addressed by the Ethernet before. Vecchio said. Tomahawk Ultra focuses on the ultra-low latency, small packet throughput, and lows lesser operation. It achieved 250 nanosecond switch latency at a full 1.2 terabps throughput that handles 77 billion packets per second, a figure driven by its ability to process minimum sized 64-byte frames at line rate. According to Broadcom, even each higher bandwidth Tomahawk 6 advanced last month and 102.4 terabps delivers only half the package per second performance. Scale-up Ethernet Tomahawk Ultra. In concert with the open standard scale-up Ethernet SUE specification, Tomahawk Ultra delivers end-to-end XPU. The XPU latency under 400 nanosecond, including transit through the switch. Notably, the switch achieved with this without reporting the proprietary protocol and closed-angle system. Instead, it retained Ethernet compliance while introducing architectural changes that reshacked-like behavior, congestion control, and packet handling at the silicon level. Optimized headers reduce overhead. One of the architectural advances in the Tomahawk Ultra is its support for optimized Ethernet headers. Standard Ethernet implementation often requires IP version 4 and UDP headers as large as 44 to 46 bytes, which significantly impairs efficiency for the minimum size packets. For AI and HPC workloads that rely on small and high-frequency messages, such as overhead consumed valuable bandwidth, and inflates processing time. The Tomahawk Ultra introduced an adaptable and compressed Ethernet header for method reduces the packet of write as well as little as 6 bytes, and these headers maintain the full Ethernet compliance into operators with the standard MAC and Wi-Fi implementations. However, they eliminated the need for multi-layer encapsulation in a tightly coupled system where the package typically traverses a single switch hub. We are showing you how you can have optimized the header that is Ethernet compliant with much less of read-on wires. There, Beggio said, this reduction in header size directly boosts the effective payload throughput for minimum size packets and simplified XPU design. It also enables the final control over traffic shaping the small flow classification for workload that is distributed across many cores. Lawless fabric with the hardware-based flow control. Tomahawk Ultra also integrates dual mechanisms to achieve the lossless Ethernet fabric. At the link level, Broadcom employs the link layer retry LLR that combines the IEEE standard fault error correction FEC with the retransmission protocol to detect and correct the frame level errors without requiring application layer intervention. Broadcom claims that this feature minimizes the retransmission of header latency so that the switches and the CPU can handle errors locally and immediately. And a working example of the lossless LLR to prevent buffer overhead overflow the switch, the edge the grid-based flow controller CBFC, and the mechanism in which receivers communicate are available buffer credit to transmitters. Transmission occurs only when the receivers indicate sufficient space. That way, it eliminated the congestion-driven and packet drops typical in low-G networks. These mechanisms are implemented entirely in hardware and operate on a per-hop basis and reducing the reliance end-to-end technologies and dramatically lowering latency. Broadcom also noted that a feature once relegated to proprietary interconnect like InfiniBand and OmniPath are now standardized under the Ultra Internet Consortium (UEC) and are incorporated directly into Tomahawk Ultra architecture. In network collectives to offer the XPU, Tomahawk Ultra introduces support for in-network collectives (INT), a feature that offloads multi-node communication patterns from XPUs to the switch itself. An INC target operate like or reduce all together and broadcast. They rely on aggregation of the partial results computed across many accelerators. Instead of forcing XPUs to handle the collective computation by exchanging the multiple rounds of data, the switch aggregates and distributes the result eternally. For example, in the low-reduce operations, each XPU sends each computed tensor to switch, which performs the summons and this distribution to find a result back to the old devices. This reduces the completion times by both rolling computation latency and cutting the total data traffic across the network fabric. Broadcom implemented INC support directly in Silicon Pipeline to sidestep and any performance penalties, accelerate the convergence of large language models, and support tight synchronization in parallel workloads. A pivot to Ethernet. According to the Broadcom, Tomahawk Ultra is a turning point in the debate over Ethernet visibility and scale of the network. And the Broadcom executives anticipated that Ethernet, while already dominant in the data center and scale of AI, will extend its reach into the scale-up domain and displace close to interconnect via NVLink and UA-Link. Even NVIDIA, their messaging has shifted pretty dramatically to be more about Ethernet. Del Vecchio said, "Are things like OmniPath and InfiniBand on the way out?" I think so. Okay, today, thank you for your time. See you next time.